Hello everyone, I'm Zhen Qin. Today I'm gonna present our project entitled How Sleep-Mediated Memory Consolidation Modulates the Generalization of Crosstalkers. We'll focus on tone identification. Sleep plays a significant role in learning, generally speaking, because learners need sleep after learning to hit the save button on those newly formed memory so that they will not forget. And specifically for language learning, it's all about memory because language learning requires a transfer of newly learned knowledge, linguistic knowledge, from vulnerable episodic memory to a more stable and permanent long-term declarative memory. And that is why sleep comes into play, because it is during the sleep in which memory consolidation occurs. So generally speaking, sleep-mediated memory consolidation, which is so-called overnight consolidation, has been found to play a significant role in novel word learning by facilitating the learning for both adults and children learning population. Specifically, the speech learning literature has found that these overnight consolidation effects actually promoted talker-independent learning by generalizing learners' knowledge from stimuli produced by the trained talker to the spoken stimuli produced by the novel or untrained talker. And most of this evidence was from Emily Meyer and her colleagues' recent research on English listeners' identification of a Hindi, dental, and retroflex stop contrast. This study focused on lexical tones instead, because different from consonants, lexical tones have unique features in its variability and diversity. At first, so tones have a great variability across talkers. And to identify a specific tone, listeners need to evaluate the pitch they hear in acoustic signal against the pitch of a given talker. But meanwhile, talkers have really different pitch ranges, so that the learners have to learn these tones regardless of talker variability, and form a talker-independent learning to categorize each tone accurately. In addition to that, so tones often have their pitch contour changing dynamically over time. So listeners need to continuously modulate and update their identification as more of the pitch contour is heard over time. And given this unique and complicated feature of lexical tones, this study, we focus on tones from Cantonese tonal inventory. So Cantonese has 3 level tones, that is tone 1, the high level tone, and tone 3, the mid level tone, and tone 6, the low level tone, which contrast in pitch height. And different from Cantonese tonal inventory, in Mandarin tonal inventory, there is just one single level tone, that is tone 1, high level tone, which does not contrast from other 3 Mandarin tones in pitch height. And given the differences between the Cantonese tonal inventory and the Mandarin tonal inventory, so the literature on tone perception has found that Mandarin listeners usually have harder time distinguishing and categorizing Cantonese level tones. And this Mandarin listeners' difficulty in perceiving Cantonese level tones allowed us to test the effect of overnight consolidation by comparing a morning training group versus an evening training group. And specifically, we investigate Mandarin listeners' talker-independent learning in their identification of 3 Cantonese level tones. It is hypothesized that overnight consolidation will help Mandarin listeners to learning from an acoustic sensory-based representation to a more abstract talker-independent representation. And to test our research question, 32 Mandarin-speaking participants were recruited and tested in Hong Kong. All of those Mandarin-speaking participants speak Mandarin at their mother tongue, had a limited exposure to Cantonese, as well as limited musical training. Those participants were randomly assigned to two training groups. One, the morning training group, who received a training, tone identification training on the morning, and the evening group, who went through the training on the evening. The participants in the morning and the evening group were also matched in their speech processing aptitude, their short-term, long-term memory, as well as their musical aptitude scores. They also had a similar tone discrimination accuracy in a pretest before they went through the tone identification or categorization training session. And to test the talker independent learning, the stimuli produced by two female talkers were used in the present study. The stimuli produced by the Zhen talker, shown in the figure on the left panel, were used in both training session as well as in the post-test sessions. In contrast, the stimuli produced by the Zhen talker, the novel talker, was only used in post-test session to assess learners' talker independent learning. And if you compare the stimuli produced by these two talkers, you will find some difference. And the Zhen talker had a smaller pitch range compared with the Zhen talker. And also the Zhen talker had a higher pitch value, overall speaking, compared with the Zhen talker. With regard to each individual tone, you will find, for instance, a mid-level tone produced by the Zhen talker had a very similar value to the low-level tone, tone 6, produced by the Zhen talker. The bottom line here is the use of the stimuli produced by these two talkers allowed us to assess the talker independent learning, because during this process, learners had to learn tone categories regardless of this talker variability so that they can identify each tone accurately. So in our procedure session, the two training groups were tested in 3 consecutive days. In day 1, the two training groups were tested in a series of pretests. And after that, they went to the training session, while the morning group received the training on the morning, and the evening groups went through the training on the evening. And right after training, so the two groups were assessed in post-test session in different times. That is, immediately after training in post-test 1, and 12 hours later in post-test 2, as well as 24 hours later in post-test 3. The essential manipulation here is sleep. There was no sleep intervening between training session and the post-test session for the morning group. However, sleep intervened the training session and the second session for the evening group, who had their newly learned tone knowledge consolidated during their sleep. And next, I will show you the learners' tone identification accuracy for the stimuli produced by the Zhen talker first, across 3 post-tests in terms of the morning group represented in red and the evening group represented in blue. So the figure showed that the two groups differed in their patterns of tone identification across 3 post-tests over time, while the morning trainees showed a declined performance of their tone identification across 3 post-tests. The evening trainees showed an improved trend of their tone identification performance across 3 post-tests. And these group differences also remained for the stimuli produced by the novel talker or the Zhen talker. So basically, this pattern was generalized from the old stimuli to the novel stimuli. Since the factor of Tucker did not interact with a group at this time, so we collect our data to compare the morning and evening groups in their tone identification performance across 3 post-tests. The post-hoc analysis showed that the morning trainees showed a significant difference between 3 post-tests in their accuracy. With accuracy of post-test 2 or post-test 3 having lower than that of post-test 1. In contrast, the evening trainees showed a marginally significant difference between the accuracy post-test 3 and post-test 1, with the accuracy of post-test 3 lower than that of post-test 1. To further investigate the relationship between the overnight consolidation and their identification performance for the evening trainees, we run a set of regression analysis with 4 sleep-related factors as predictors on their identification performances over time. So these 4 sleep-related factors were the evening trainees' self-reported sleep duration and hours, their self-rated sleep quality, their sleep time in which they fell asleep, and their wake-up time as predictors. And we found only sleep time predicted the evening trainees' identification changes 12 hours later, as well as 24 hours later. And this figure showed exactly the predicting relationship of the sleep time, the time in which each evening trainee fell asleep, and their identification changes 12 hours later. So the declining regression line showed, the earlier a participant fell asleep, more likely it was for them to have an improved trend of their identification performance. To wrap up and to discuss the implication of our results. So the group results, the group differences between the morning and the evening group in their 3 post-test, regardless of the stimuli produced by the trained and talker showed, the sleep intervening training and the post-test session actually facilitate talker independent tone learning. Specifically, the overnight consolidation predicted the evening trainees' identification of novel tonal contrast against the subsequent decay, and further induced a trend of sleep-related improved identification performance. Meanwhile, we did not find a significant improvement for the evening trainees, which was different from the findings of previous studies on the Hendy-stop contrast. This discrepancy was probably due to a greater variability induced by our tonal stimuli used in the present study. Given its greater variability in syllables and the contrast, so this greater variability made our stimuli more challenging for learners to learn perceptually. In addition to the overnight consolidation account, an alternative account was interference effect. So the difference between the morning and the evening group was simply driven by the morning group's decline in performance. So compared with the evening trainees, the morning trainees had many things to do in their weekend lives, and that's why they were more vulnerable to interference or disruption than the evening trainees who received less interference after the training. While these interference accounts are able to account for the morning trainees' decline in performance, it did not necessarily account for the performance of the evening trainees who were also exposed to some extent interference, but did not show any decline in performance. Essentially, they also showed a trend of improved performance across time. This evidence supported our overnight consolidation effect. And besides that, the evening trainees' relationship between their sleep-related factors and their identification changes also support our overnight consolidation account. To test about these two possibilities, our ongoing and future experiments are recruiting two training groups who both were trained in the evening with their interference and disruption before sleep well controlled. And then in the meanwhile, we are also investigating the relationship between learners' fine-grained sleep-related factors, such as sleep duration or different sleep stages, on those facts of sleep-related factors on their tone identification changes over time. So last but not least, I would like to show my gratitude to my collaborator, Professor William Wang, and the funding agency. And if you have any questions or comments, please contact me. Send me an email. And also, you could find more information of this project in our research files. That's all for my presentation, and thank you.